Hi guys, we're going to go through working with fourth degree polynomials, finding all zeros. So we've done a lot of synthetic division with the third degree polynomials. At the end of class we talked about possibly doing it with the fourth and having to use synthetic division twice to get it down to a quadratic. So if this is your initial equation, f of x equals 3x to the fourth minus 8x to the third minus 37x squared plus 2x plus 40, we want to list out all possible rational zeros. So factors of 40 divided by factors of 3. We list those out, and we have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, 8, 10, 20, and 40, all over factors of 3, which are plus or minus 1, plus or minus 3. When you list out all of the possibilities, we have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5 over 1, plus or minus 8 over 1, plus or minus 10 over 1, 20 over 1, 40 over 1, along with going divided by 3. So 1/3, 2/3, 4/3, 5/3, 8/3, 10/3, 20/3, and 40/3. Whoa, that's a lot of possibilities. So instead of trying each one of those out separately using the synthetic division or the remainder theorem, I'm going to allow you to cheat just a little bit, in which case we're going to look at the calculator to help. So the first thing you want to do is to put it into y1. So if you go into y equals, you should enter in your equation, press graph, and we want to look and say, okay, this looks as if it passes through -2. That one kind of looks like it's a little past 1, so we want to hold off on that one and use really the whole numbers. But that could be our, say, -4/3. Let's say 1 and 5. So using the calculator, you want to think about a couple possibilities and see if those ones actually work out versus testing every single one of these. So let's try 1 because that's usually our easiest. So we set up 1 with our coefficients, bring down the 3. So now you have 3 times 1 is 3. -8 plus 3 is -5 times 1 is -5. -37 and -5 is -42. Times 1 is -42. If I add those two, I get -40. Times 1 is -40, and I get 0, which means that x minus 1 is a factor. But now this was a fourth degree polynomial, and now it's only a third degree polynomial, which is still not something that we can factor just yet. So using one of the other possibilities, either the -2 or the 5, we're going to try it again. So if you use 5, bring down the 3. And again, you'll notice that it's using your leftovers from your first time that you use synthetic division. So again, we're starting with the 5, and now the 3 comes down. 3 times 5 is 15, gives you 10. Multiply again, that's 50. If I add those together, that's 8. Multiply again, I have 40. And again, I get 0. So that shows that x minus 5 is also a factor. So you started with the fourth degree polynomial, working your way down to a third degree would be here, but since we did it again, we're now at a second degree polynomial. So if you're starting with f of x equals x minus 1, that was my first factor, x minus 5, that's my second factor, and I'm left with 3x squared plus 10x plus 8, which is what's remaining here. From here, you can either factor using guess and check or bottoms up, or quadratic formula, in order to solve what each of your zeros would be. We're going to get to this a little later on. This is called linear factorization, when all of your powers are to the first power versus something squared. So this is going to be ideal to get there one day, preferably today or tomorrow, to use linear factorization. But again, if it doesn't factor, you can still solve using quadratic formula. And so setting each of our factors equal to 0, you end up getting with 1, 5, -4/3, and 2.